Hi. Now in this video what I want to do is show you how we can combine transformation matrices, and I'm assuming that you're familiar with these particular matrices. I've called them R90, which represents a rotation of 90 degrees anti-clockwise centre the origin, and then we've got similar results for R180, rotation 180 degrees, R270, rotation of 270, and finally R360, rotation of 360 degrees. And these matrices, remember, are built up from the unit base vectors, okay? These ones here, 1, 0, 0, 1. So for instance, rotation of 90 degrees, we just look at where 1, 0 goes. When you rotate it 90 degrees, it goes to 0, 1, and you write that here. And then you look at this unit base vector 0, 1 and rotate that 90 degrees, and it goes to this position here, minus 1, 0, which should write down here. And you've got similar results for all of these. And if you're unsure of these transformations, you can just check them out in earlier tutorials on my website. Now, on that basis that you're familiar with these transformations, let's see what happens when we start to combine two rotations. Let's just suppose we look at R90, a rotation of 90 degrees, combined with another rotation of 90 degrees. Now when we combine transformation matrices, we multiply them together. So what would you get then if you multiplied a rotation of 90 degrees with another rotation of 90 degrees, this matrix here? You might like to pause the video and just work out this product. Okay, well if you did pause the video and had a go, then you should have found that you got this answer, the matrix minus 1, 0, 0, minus 1. And when you look at that matrix, it happens to be this one up here that represented a rotation of 180 degrees. Let's just put that in, that it's a rotation of 180 degrees. So if we rotate 90 degrees and then rotate another 90 degrees, then we get a rotation of 180 degrees. So it seems as if we're just combining our rotations then. Let's try another one. Now in this question, I'm going to look at a rotation of 90 degrees followed by a rotation of 180 degrees. And you've got to be careful with these questions because you've got to check out the order that you put the matrices down. It's a rotation of 90 degrees that you do first on any shape, followed by a rotation of 180 degrees. So it's going to look something like this. R180, then R90. Check that order out. Because remember, if you were doing this on a shape, your shape matrix would be written, say, here, and you would do a rotation of 90 degrees on the shape matrix first. You'd get an answer, and then you would rotate that by 180 degrees. So, hope that makes sense, okay? So again, you might like to check out the matrix multiplication for this. What we've got then is those two matrices, the matrix then for 180 degrees and the matrix for a rotation of 90 degrees. So what do you get if you multiply those out? Well, again, you might want to pause the video just for a moment, check it out. Okay, welcome back if you did have a go. Well, you actually end up with this matrix, which is the matrix for a rotation of 270 degrees about the origin. So you can see that this combining of matrices seems to work, and indeed it does. Let's look at another one. Okay, we'll just come down here and border this off. Okay, this time going to look at a rotation of 90 degrees followed by a rotation of 270 degrees. So again, check that out, the way that we are doing this. It's the rotation of 90 degrees which comes first. We're operating on a particular matrix, say, of a shape. That comes first, and then we follow it with a rotation of 270 degrees. It's not written the other way around. Okay, might like to give that one a go. Just pause the video, come back when ready, and I'll show you the solution. Well, again, with this one, we'd have our two matrices then, and when we multiply them out, what we get is 1, 0, 0, 1. And 1, 0, 0, 1 is a rotation of 360 degrees. It keeps us in exactly the same place as we started. In other words, it's called the identity matrix, I. And that shouldn't come as any surprise from what we've been talking about already, that combining these transformations, if you do 90 degrees followed by 270 degrees, you're going to rotate then a total of 360 degrees, bringing you back to where you started. Okay? Now, what I'd like to do is just carry on with another type of question. We've been looking at rotations, but what about if we now start to look at reflections? So if we look at reflections, we should be familiar with these two matrices. Reflections in the x-axis, 1, 0, 0, minus 1, and the reflection matrix or the y-axis, minus 1, 0, 0, 1. Now with this one, what I want to look at is how we can combine these two matrices, and it will represent another transformation. In fact, you might like to combine these two transformations, which is a reflection in the y-axis first, followed by a reflection in the x-axis, and tell us what you get. So again, pause the video, have a go at this, and see if you can work out what overall transformation this represents. Okay, welcome back if you had a go. So in the usual way, we'll put down our two matrices, Rx here and Ry, multiply them out, and you get this matrix here. And what does this represent? Well, we can see that it represents the matrix up here, a rotation of 180 degrees, centre the origin. So we'll just pop that in there. And I can demonstrate that this works just by taking a particular shape on a grid. Let's suppose we have this triangle here drawn on this grid. Now, if I do Ry first of all on this shape, a reflection in the y-axis, then that triangle will move over to here. And now I'm going to follow this with Rx, a reflection in the x-axis. So it's now going to move down to there. And finally, can you see that we started from here, we've now ended up here. And what this is a rotation of 180 degrees, centre the origin. And so combining matrices tells us exactly what we would expect for the overall matrix transformation, which can be very useful. Okay, well, I hope that's given you some idea then how we can go about these transformations. It doesn't just stop here where you're multiplying, say, or combining two matrix transformations. You can have more. You can have 3, 4, whatever, but it still follows the same rule. And that is, remember that when you have one transformation followed by another, the first transformation appears on the right hand side, and then you work your way back to the left. Okay?